So we're going to look at factoring quadratics where a is not 1. So factoring quadratic trinomial, I guess we'll get specific, when a does not equal 1. So remember, quadratic trinomials come in the form ax squared plus bx plus c, and we're saying a is no longer 1. It's the exact same process when a is 1, but now your final answer isn't going to be factors with just a degree or with a coefficient of 1x. It's going to have another coefficient. So we're still going to follow the same steps. And I'll write those out after we do our first example. So we'll have 2x squared minus 11x plus 12. And so we're still going to draw our x. On top, we're going to multiply a times c. So we're going to have 2 times 12, which is 24. And b is on the bottom. And we're thinking of two numbers that multiply to give you 24, but add to give you negative 11. And so after thinking about it, you should come up with negative 8 and negative 3. And then we're going to rewrite our trinomial in 4 terms. So we'll have 2x squared minus 8x minus 3x plus 12. Even if you came up with two different numbers, well, you couldn't come up with two different numbers. Even if you wrote these over here in a different order, so the 3 and the 8 were reversed, it would still work out. So it doesn't really matter. Now that we have 4 terms, we want to factor by grouping. Take out our GCFs. And then we're going to take out our common factor and put our other stuff together. So notice that this factor has a 2 with the x and has a different coefficient. And so that's it. It's factored completely. So very similar to what we did when the quadratic trinomial a was 1. So I'll write out those steps. So you'll have your x, a times c up top, b on bottom. You're still finding two numbers who multiplied equal a times c and added gives you b. So shorten that just a little bit. And then you're going to rewrite the middle term. So you've got 4 terms. And then you're going to factor by grouping. So we'll do another example. If you look up on YouTube ways of solving quadratics where a is not 1, there's a bunch of different methods out there. So if you want to look up a different method, that's fine, but we're going to stick with this one. So sample 6x squared minus x minus 2. Draw our x, multiply a times c, negative 12. B is on the bottom, negative 1. And I need two numbers that multiply to give me negative 12, but add to give me negative 1. Well, we got negative 4 and positive 3. That should work. We're going to rewrite our middle term. So 6x squared minus 4x plus 3x minus 2. So remember, negative 4x plus 3x equals negative 1x. And so it's still a true statement. It's still equivalent. It's still equal. We're just mathematically changing it. And then we've got 4 terms, so we're going to factor by grouping. And so we'll take out our GCF. So we'll take out a 2x. That leaves me with a 3x minus 2. And then over here, we've got a 3x minus 2. They don't have anything in common, so we're just going to take out a 1 as like a placeholder. And then my factors are the same. So we'll have 2x plus 1 and 3x minus 2. Voila, it is factored. So next, we're going to solve by factoring. And when we solve, what we're finding are the x-intercepts, so where it crosses the x-axis. So this example, we'll start with a 4n squared minus 8n minus 21. we will still draw our x. We're multiplying our first term times our last term. 4 times negative 21 is a negative 84. That seems like a really big number. And then we've got a negative 8. So let's see. 84, let's list out our factors since that's such a big number. We've got 1 and 84, 2 and 42, 3 and, let's see, 3 and I'm having a hard time doing that. 3, let's see, 84 is divisible by 3. Working backwards, 3 and 28. Let's see, 4 and 21. 5 wouldn't go in, 6 and 14. Oh, and I think we just found it, so 6 and 14. So since that 8 is negative, we want the bigger number to be negative, so negative 14 and 6. So sometimes it just takes a little bit of trial and error and knowing your multiplication facts. And so then we're going to rewrite it. So 4n squared minus 14n plus 6n. Oh, not minus 8, minus 21. We've got our 4 terms, so we're going to group them together and then take out a GCF. So we'll take out a 2n. That leaves me with a 2n minus 7. Between 6n and 21, I can take out a 3. That leaves me with a 2n minus 7. And then my factors are 2n plus 3 and 2n minus 7. So remember the direction said to solve. So really we should have an equals 0 out here. And so to solve, all we have to do is set both of those factors equal to 0. Oh, I've got a n. Divide by 2. So 1 is a negative 3 halves, and we'll just leave it as a fraction. And then we'll write it as a solution set. Either one works, just solving it for n or writing it in the solution set. So I want to do one more, maybe 2. We'll do one more solving, and then we'll do one with a mixed GCF. All right, so I have another one. So we will solve, and we'll do 3x squared plus 14x minus 5. Draw our x off to the side. 3 times negative 5 is a negative 15. 14 goes on bottom. 2 numbers that multiply to give me negative 15, but add to give me 14. Well, those are really close together, so I'm thinking it's going to be negative 14 and negative 1. No. 15 and negative 1. I was thinking it backwards. Just on a roll today with mistakes. Alright, so 15 times negative 1 equals negative 15. 15 plus negative 1 gives me a positive 14. So, fix that. That's good. 3x squared, we'll rewrite it as 4 terms. And then since we've got 4 terms, we can factor by grouping. Take out a GCF. Here we'll just take out a negative 1, and that guarantees that my factors match. So my factors are 3x minus 1 and x plus 5. Since the direction said solve, technically it's equal to 0. And then we're going to set both of those factors equal to 0. And then we will solve. And so I'm solving really quickly, but you can pause it and solve it just to make sure you know how as well. So my 2 solutions should be negative 5 and 1/3. All right, we're going to do one more example because I want to show you that you still can take out the GCF and it still works for this factoring method as well. So let's look at let's do 16x squared plus 60x minus 100. And we're just going to factor this one, we won't solve. So if we were to multiply this a times c, we would have 1600, so 1600. And we would have to find numbers that multiply to give us that, but also add to give us 60, which may not seem that bad because we're dealing with zeros in this particular one. But sometimes we get some really big off-the-wall numbers that I don't know what the factors are. So we always want to take out the GCF. And so by taking out the GCF, hopefully we'll deal with numbers that we're more familiar with. So this GCF and this one appears to be a 4. So 4 goes into 16 4 times, and 4 goes into 60 15 times, and 4 goes into 100, well, it's like quarters, 25 times. So we'll take out a 4, and so that leaves me with a 4x squared plus 15x minus 25. And so those numbers are a little bit smaller and a little bit easier to deal with. So we're going to follow the same steps. So multiply a times c. 4 times a negative 25 is a negative 100. And then on the bottom we'll have 15. So we need two numbers that multiply to give us negative 100 but add to give us 15. So factors for 100, 1 and 100, 2 and 50, 4 and 25, 5 and 20, 10 and 10. So 5 and 20 looks like our best bet. Since the 100 has to be negative, but the 15 positive, we want our smaller number to be the one that's negative. And then we'll rewrite it. So keeping that GCF on the outside, we'll have 4x squared minus 5x plus 20x minus 25. We've got 4 terms, so we'll factor by grouping. Don't want to forget that GCF. And then we'll take out an x, so leaves me with a 4x minus 5. Here, let's see, we can take out a 5, and that leaves me with a x minus 5. They match. And so my final answer would be 4 times x plus 5 times 4x minus 5. And so very similar to factoring when a is 1, same process. So should be pretty straightforward.